Hey, welcome back AP Calculus students. Today we're looking at 6.2 definite integrals. So this is more of a notation thing to begin with. We're still talking about integrals, which means we're trying to find the areas under a curve. One way that we can look at it is using a Riemann sum. So this is the one on the left-hand side. It's the limit as n approaches infinity. And this is summation notation, meaning we're adding up all the areas of these rectangles from n to from k equals 1 to n, and then the function is f parentheses c sub k, and then change in x. Right, so what this means is that this is remember we're making rectangles, right? So this is the base of our rectangle, like we were doing in last class when we're doing the MRAM, RRAM, and LRAM. This is the function value, right, which is how we get our rectangle, right? Function times the base, and we're adding up all these small rectangles infinitely. So we're trying to have infinitely many rectangles that add up to the total sum of the area under the curve. So if you think about it, let's kind of draw it here. If we draw these rectangles ever and ever smaller, infinitely small, or infinitely wide, or infinitely small, to fill up each of these little spaces underneath the curve, then we should get the exact value, is what they're trying to say. And then it says on interval AB, so that means just from wherever we start to wherever we end. So A is the start, B is the end. Now let's look at the integral notation, because the integral notation is the one that you're going to be using going forward, and it's really elegant because instead of all this stuff for the Riemann sum, we can say the same thing just using an integral. So A is the start, B is the end, and then we're just going to say f of x dx. That's the same thing as we said here, but in a nice simplified way. Okay, so the first thing it's asking us to do is express the limit as n approaches infinity, the summation of n from k equals 1 of 3 parentheses m sub k squared minus 2 parentheses m sub k plus 5 delta x as an integral, right? So like we said, for our integral, we just have to say where we start at, which is A, where we end at, which is B, and then because we have an actual function in here, let's write the function. So all we have to do is replace all those m sub k's with an x. So 3x squared minus 2x plus 5. And rather than say delta x, we're going to say dx. Okay, so very simple to convert from the Riemann sum to the integral. Okay, the next part is asking us to evaluate from, this is the start, -2, to the end, which is +2, this function dx. All right, so if we were to graph this out, because we don't know how to do this, the integral yet, eventually we will, and we can do this without having to use this method, but because we're here, we'll take a look at it. So what this is it's just a half circle from -2 to +2. Okay, so if we're trying to find the area under this half circle, well, that's pretty easy. We just have to find the area of the full circle and half it. So let's go ahead and do that. Notice that our radius is 2. And if we're trying to find the area of a circle, we know that's pi r squared. So we're going to do pi times 2 squared, which is 4 pi. And because we're only having half of this circle, we just got divided by 2. So this is going to be 2 pi. And we'd say units squared. Okay, and then if you didn't know that this is a half circle, you could definitely just graph it, right? So just take your function, graph it, recognize what shape it is, and find the area under the curve. So like even if it were a rectangle, right? Or some kind of triangle, we could definitely find the areas under these curves by using one of the geometric shape formulas that we already know. Okay, on to the next stuff. So these are just some notes here for our area. If we have area where f of x is less than 0, so anything underneath the curve, so let's say we have a sine graph like this, right? Any areas underneath the curve are just going to be negative, right? So areas under the curve, under x-axis, I should say, x-axis are negative, or is negative. Area under the x-axis, that's terrible grammar, is negative. Okay, so that's just the first thing that they want to note. And they also want to note that for a function, like say we look at this again, if we're talking about the sine function, what this actually is going to be 0 if we go from 0 to 2 pi. And the reason is because the area above the x-axis is equal to the area below the x-axis. So when we do functions that are above and below, we have to take the area above and we have to subtract the area below, which is why we get 0 for our sine. Okay, that'll come into play later, but they do want to make a note of it now. All right, and then the example 3 is pretty straightforward and easy. So it says a ship sails at a steady 7.5 knots from 7 to 9 a.m. Express the distance traveled as an integral. And then it says evaluate using theorem 2. Okay, so we're going to say we start at 7, we end at 9, and then our function is 7.5, right? Because it stays at that steady rate. Okay, so what theorem 2 says is that if we have an integral with a constant, like we do here, 7.5 is our constant, then all we have to do is take our constant, which is 7.5, and multiply by b minus a, which is the start, which is the end minus the start. So 9 minus 7 is 2. So this thing is going to be 15 miles that we traveled. And if you think about this, not using your calculus brain and just thinking of it in the simplest terms, if this thing is going the same speed for 2 hours, then the area here is definitely going to be 15, right? 7.5 times 2. Or the easiest way to think about it is if you travel 7.5 knots per hour for 2 hours, it's just 7.5 times 2. So yeah, just reiterating that some of these things are pretty straightforward. It's just they're relating them back to calculus. All right, and the next thing we're talking about is the accumulator function. So notice in this one, the x is unknown, right? So the ending part is unknown. We know where we're starting. We're starting at a, and we have a function in terms of t. So if we're going to do this, it says let f of t equals 1 plus 2t, and t is between 1 and 6. And it's saying here's the accumulator function. A of x equals 1, the integral from 1 to x of 1 plus 2t dt. Find the accumulator function. So let's kind of look at what this is. So this is our function 1 plus 2t. So what we know about that is it starts at 1 and it has a slope 2. So if we drew it, it kind of look like this, right? And then we're going from 0 to 6, 3, 4, 5, 6, up there. So what it's saying is we want to find the area in the curve in general terms. So we don't know where the x is. X could be anywhere, right? So we want to use this function that's going to tell us wherever x is, whatever endpoint is, how much area is under the curve. So let's go ahead and figure out how we're going to do that. Well, we can use that as a trapezoid, right? Because that's a trapezoidal shape under the curve. But I think it might be easier if we do it this way. So notice that this rectangle here, we're going to do it as the area of a rectangle plus the area of a triangle, right? We're going to split this trapezoid into two pieces. So the area of the rectangle is always going to be x because it's going to be 1 times x. So area of the rectangle is going to be x. Now the area of the triangle is a little bit trickier, right? So the base is going to be x. The height is going to be the height of the function. So 1 plus 2x, wherever x is. And then divided by 2. Okay, so if we add these two things together for any of our, then if we add these two things together, we should get the value of our rectangle. So x plus, we could distribute this out. X times 1 is x. And then x times 2x is 2x squared. I don't think we should say equals 0. Okay, so we could leave it like that. In fact, let's see what they say in the book. I think this is fine. Area of the rectangle, area of the triangle. Yeah, this works out. This is okay. All right, the last thing we're gonna do is some calculator work. So we're gonna figure out how to find the integral using our calculator. Okay, we have our calculator set up. So the key here, like it says on the top, is we're going to press math, we're going to press 9 or scroll down to fn int. And what that's going to allow us to do is set up our integral. So the first one is from -1 to 2 of x sine x dx. Okay, so let's go ahead and do our math here. We're going to hit math. 9 is fn int. And all we're going to have to do is set up our integral. So from -1 to 2, and our function is x sine x. Close up our parentheses, and then dx. And it'll give our value, 0.052. So this is going to be 0.052. Same with the next one, from 0 to 1, 4 over 1 plus x squared. Okay, so from 0 to 1, back to math 9, from 0 to 1, and then 4 divided by, make sure you put this in parentheses because it's the whole denominator, 1 plus x squared, close that bottom parentheses, dx, which is 3.142, which is pi, 3.142. Okay, and then the last one, e to the negative x squared from 0 to 5. Math 9 from 0 to 5. e to the negative x squared. So e to the negative x squared dx. 0.886. So that one's going to be 0.886. Oops. Okay, and that's it. So yeah, ending with the easy thing, just making sure you understand how to use your f and int on your calculator. All right, good job.